Hey guys, today in this video we will look at the problem that is solving the A-star algorithm. In right side we have a graph in which A is connected to B, A is connected to C, and D is a node which is connected by B and C. As you can see, A is our start node and D is our destination node. From A to B, cost will be a 2. A to C, a cost will be 3. From B to D, a cost will be 1. And C to D, a cost will be 1. We have a heuristic value for every node. Say for node A, we have a heuristic value 10. For B, we have heuristic value 5. For C, we have heuristic value 6. And for D, which is our goal state, that has heuristic value 0. So we need to find a path in which we have to traverse from A to D, uh, in which it will give a minimum path. Like as you can see, from moving from A to B and B to D will give me the shorter path, whereas if I go from A to C and C to D. Okay, so without wasting much on this, we'll dive on this uh, code. So as you can see, we have a function called as a star, which take a start node and goal node, and we have a graph which is passed here. Okay, below. So we have also we have a front tire. Front tire is nothing but a lit, which will be which type of heap, which will be a mini heap. Simply we are pushing a start node, which is a cost will be a 0. Okay, we have a dictionary called as a came from. That means we are reaching at D, right? We need to know that from where we came a D. Suppose we came from B, means D is came from B, whereas B is come from A. Okay, whereas A is come from which? A is come from none. Okay, that's what we are adding here. Came from start will be adding none. And we have a cost so far. Cost so far is a list in which we need to find that we are at C, right? If we are at C, to reach C, how much cost will be done? That's what. We are at initially we are at A, right? We are at start node. The cost will be a 0. That's what we written here. And we have a path. It will be used to print this path. Okay, the main logic will be in a while loop only. So you can see that okay. Okay, we have in a heap. In a heap, we are inserted cost of 0 with the node A. Now we are popping this A. We are storing at current. My current will contains the My current contains heap.pop front tire of 1. Heap.pop will give me the list in which I need a first index. That means I'll get A. Okay, I'll check whether if my current is equal to my goal state or not. My current is A. A is not equal to my D. So it won't satisfy this condition. Directly it will go move on to this for loop. So I am at A, right? I need to look at the breadth first. Like I need to look at the child of A, that is B and C. Okay, so we have a for loop in which node cost in graph of the current, which A is connected to B and C, right? A is connected to B and C. So we'll get the children of A, that is B and C. So our new cost will be cost so far of current plus cost. That means cost so far of A is 0 plus cost. Cost will be to reach B I need to give 2. So now new cost will be 2. Then we have a if condition, that is if my node, that is B, it is not in a cost so far, or if my new cost, if it's a new cost which is less than the cost so far of a node, means we have to do a cost so far of node which is equal to a new cost, and we have to make a priority in which it contains a new cost plus heuristic value of goal plus heuristic value of node. Then we are pushing into our min heap, Then we are adding to reach b, to reach node which is my parent, that is current. To reach b, my parent is a. I'm writing like this. Okay, so it moves on, like it adds c also, and from it will take the minimum, that is b. And from b, which are the child are there? B, child of b is d, right? So I'll add d. D will be my goal state, and I'll break from here. So next I'll print the uh, path. How I'll print the path? Suppose I'll take a variable n which will be equal to goal, and I'll run a loop where n is not equal to none. Okay, each time I'll add the path dot append the n. Okay, n is equal to came from of n. Then I'll reverse the path and I'll print the path. Okay, this much. If I run this code, so as you can see, a to b and b to d.